Welcome to today's video that is all about numbers. There are only 4 numeric types in Python: integer, floating point, Boolean, and complex. Let's talk about integers first. Integers represent whole numbers, and Python will understand that we want to create an integer when we assign a name to a whole number such as 2. Integers are among the more boring types, so let's get straight to floating point numbers. Floating point numbers are used to represent decimal numbers, and Python creates a floating point number when we assign a name to a decimal number, where the decimal is indicated by a dot. A floating point number or float is also created when we divide two integers, because the result of this division could be a decimal number. If you absolutely need an integer, you can call the int constructor. The int constructor will convert any number that we have within the parentheses to its integer form. The integer form of 2.5 is simply 2, because the decimal part is cut off when converting like this. If we want to round up or down, we have to use specific functions which we will learn about at later points. Alternatively, we can also use the double division operator. When dividing with the double division operator, the result is an integer. Conversion also works the other way around, so we can convert an integer to a float. When we do this, the decimal portion is simply 0. The results of the other mathematical operations between two integers are always integers. For example, addition, subtraction, multiplication, power, and remainder. When we mix an integer with a float, the result is always a float. For example, addition, subtraction, multiplication, power, and remainder. Our last type for today is the Boolean type. We can create a Boolean by assigning a name to true or false. A Boolean value is used to make decisions in our code. It decides if something is true or false. Looking at the values true and false, it is not immediately obvious what Booleans have to do with numbers, but let me explain. Essentially, false behaves like a 0 and true behaves like a 1. For example, 5 times true equals 5, because 5 times 1 equals 5, and the result is the integer 5. 5 times false, on the other hand, equals 0, because 5 times 0 equals 0, and the result is again the integer 0. We can also illustrate the relation between Booleans and numbers by looking at the integer representation of Boolean values. To do so, we call the integer constructor as usual, and we pass it the value true. Because true behaves like a 1, its integer representation is 1. Therefore, the integer representation of false is 0. We can also turn this concept around by getting the Boolean representation of numbers. I hope it makes sense by now that the Boolean representation of 0 is false, and the Boolean representation of 1 is true. One interesting thing is that we can create a Boolean representation of any number, not only 0 and 1. When we do so, any number that is not 0 is considered true. The examples I just showed you are sometimes used in real code to find out if a certain number is 0 or not. But the most common way to create Boolean values is by using what is called Boolean operators. One commonly used Boolean operator is called the equality operator, and we use it with the double equal sign. The equality operator returns true whenever the objects on both sides are equal. For example, 5 equals 5 is very obviously true. 5 equals 2, on the other hand, is obviously false. Now this wraps up our look at numeric types. I will skip the complex type because complex numbers are mostly used by engineers and I myself rarely use them. I think for most people it would only complicate their introduction to numeric types. Should you ever need complex numbers, I left a link to the official Python documentation of the complex type in the description. Boolean types deserve their own video because they are really good at making our code smarter by making different decisions. There are many more Boolean operators that we should talk about in a little more detail. Numbers will of course come back all the time during this series, but we covered the most important aspects of integers and floating point numbers. We are almost ready to write our first program, but before we need to talk about an object that is used to store other objects. This object is called a list and is extremely useful to organize our programs. We will talk about lists in our next video. See you then.